These problems involve a system of equations involving two triangles, one inside of another, in which we don't really know anything about the exact lengths of any of the three sides. We only know the portion of one of the sides. So this problem is a good example of how we will deal with that situation. Okay, so reading on, Marla needs to find the height of a building. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74.2 degrees. So that situation is going to look like this. Here's our building, and here's a point on the ground that creates an angle of elevation of about 74.2 degrees. Okay. Marla then walks 35 feet back from the building, and from this second point, she notices that her angle of elevation is 51.8 degrees. So this is 35 feet that she moved back. It's 35 feet. Okay, so the question is, what is the height of the building? So we want to find height. And we don't know what this length is here, her original point from the building. So we're going to call that x. Now from this point, we're going to make up two equations that deal with both the blue inside triangle and the red triangle. We're going to set them equal to each other by solving for one of our variables, h in particular, and then we're going to solve from there. So our blue triangle, we can say that the tangent of 74.2 degrees, oops, a little big on the degree symbol there, is equal to the opposite over the adjacent, x over h. And so in this case, if we solve this equation for h, we will get x times the tangent of 74.2 degrees equals h. Now in our red triangle, we're going to come up with the tangent. The tangent of 51.8 degrees is equal to the height of the building divided by this whole side, x plus 35 feet. Notice how I put parentheses around there because that does signify, x plus 35 signifies the length of that side of that triangle. So I'm going to solve this equation also for h. And so when I do that, I'm going to multiply both sides of this equation by x plus 35, and it will cancel on the other side. So x plus 35 times the tangent of 51.8 degrees equals h. Now, another thing to be careful for here is that this is just a number and it needs to be distributed to both of these terms. So in the end, it's going to give us x tangent of 51.8 degrees plus 35 times the tangent of 51.8 degrees, and I got to sneak this in here, equals h. Okay, so we have two equations that equal h. We have this one equaling h and this whole one equaling h. So there we go. We're going to set them equal to each other. If they both equal h, we can set them equal to each other. So x times the tangent of 74.2 degrees is equal to x times the tangent of 51.8 degrees plus 35 times the tangent of 51.8 degrees. Okay, now I have two terms that have x in them. I have this one and I have this one. I'm going to subtract this this one right here to the other side so that my x terms are together. So x tangent 74.2 degrees minus x times the tangent 51.8 degrees equals 35 times the tangent of 51.8 degrees. And now, because I have two x's on that side of the equation, I'm going to factor out the x. So I'm going to factor out that x and that x. So I will get x times tangent of 74 degrees minus the tangent of 51.8 degrees equals 35 times the tangent of 51.8 degrees. Okay, now this, if you recall, is just a number. This whole thing is just a number. So I'm going to divide both sides of the equation to solve for x by that number, which is this little bit complicated looking expression. Tangent of 74. Now you have to be careful when you put this in your calculator. You want to make sure you close off that parenthesis and the tangent of 51.8 degrees. Close that parenthesis. And I would actually do these separately. I would do the numerator and I would store it in your calculator, maybe under n for numerator, and then I would do this one separately and I would store that for D or leave it as your answer so you can recall it, and then when you do all that you will get that x is approximately 19.65 feet. But guess what? X isn't really what we're solving for. What we really want to solve for is the height of the building. So if you recall up here, we can go back up to this equation and we can say, well, if x, or 19.65 times the tangent of 74.2 degrees equals h, and if you do that properly, you'll find out that h is approximately 69.451 feet, or 69.5 feet. Now that was a lot of algebraic work. You just have to be really careful to distribute. You need to be careful to put parentheses around your angle measures when you're entering them into your calculator, so you just don't make a calculator error. We'll do another problem on the next page. Okay, in this problem, Susan is standing to the west of Big Ben. So here's Big Ben. If she's standing to the west, we might as well just draw it in what we would consider to be west. We don't know how far away from Big Ben she is, but we know the angle of elevation to the top of Big Ben as she's looking at it is 65 degrees. And then Jordan is 35 meters behind Susan and also in the same direction, directly west. And his position, the angle of elevation, is 49.5 degrees. So he's 38 meters behind her. Okay, so the question is, again, how tall is Big Ben? And we don't know how far Susan is from the clock. So, okay, so we want to know how tall Big Ben is, and in the end it says assume they're observing from a height of 1.7 meters, so we will add that to our final total of the height that we calculate. Alright, so we're going to set up our two equations. The first one being that the tangent of 65 degrees is equal to the height over x, And the other equation relating to the second triangle with Jordan is the tangent of 49.5 degrees is equal to the height over his distance from the tower, x plus 38. Okay. So we're going to substitute, or we're going to solve both of these equations for h. This one will multiply by x. This one's easy. The other one, we're going to be careful to treat this as a binomial, and we're going to multiply by the entire binomial, x plus 38 times the tangent of 49.5 degrees equals h. So now we're going to set them equal to each other. X tangent 65 degrees equals, and I'm going to go ahead and distribute this right now just so I don't have to write it twice. X times the tangent of 49.5 degrees plus 38 tangent of 49.5 degrees. Okay, that's a plus. Alrighty, so we want our x terms to be together, so I'm going to subtract that term from this term, and I'm going to factor out my x's. I'm going to do it all in one step. So imagine subtracting this term and then factoring out the x, and that will leave me with x times the quantity, the tangent of 65 degrees minus the tangent of 49.5 degrees equals 38 tangent 49.5. The algebra isn't really that hard on these problems, it's just that it's cumbersome. And I need another parenthesis there. Okay, I'll move this up. And so I'm going to take the equation and divide it by this number. Okay, again, awkward, but not that difficult. And you have to be really careful when you put this in your calculator. Again, I would determine the value for the numerator separately and store it in the calculator, and then calculate your denominator separately, and then do the division in the calculator. And you know, when you store them, use something that makes sense to you. So maybe I might store 38 tangent of 49.5 degrees under n. That would be for numerator. And then the denominator I can just actually keep in my calculator and use second answer. Okay, so this should simplify, if you do it correctly, to 45.696 meters. Okay, and that is Susan's distance from the tower. Okay, so we really want the height of Big Ben, and we know that the height is equal to, keeping it easy, x times the tangent of 65 degrees. I didn't have my picture in front of me. Okay, so that would be h is equal to 45.69 times the tangent of 65 degrees, which should be approximately 97.995. Probably would just round that to 98 meters away, or tall, 98 meters tall, but we want to add their 1.7 meters to the total height, and that would give us Big Ben's height at approximately, approximately is these little squiggles, approximately 100 meters. Okay, so there we go. So we didn't know any of the sides of these triangles, but we knew a portion of one of the sides, but we were still able to make a system of equations based on the two triangles that we had, and we used actually substitution to solve that system of equations, and we were able to come up with two sides, and as you know, we could have come up with the third side if we needed it. Anyway, so just be careful on your algebra steps. Thanks for listening.